Okay, number 8 in our 4.7 packet, which is actually number 7 out of the textbook right here, says that a length of wire 12 meters long is going to be divided into two pieces, and those pieces then are going to be bent into a square and a circle. So what's going on right here? We have a long wire right here, and that total wire here is 12 meters long, and it's going to be broken into two pieces. Now, I don't want to make the assumption right here of thinking that they have to be equal to each other, so I'm going to kind of intentionally draw that red point a little bit off to one side. Hey, and if they do end up being equal, that's just fine. One of those pieces I'm going to call X, and the other one of those pieces is going to be called Y. So right away, I think you guys can tell that my first step, my parameter right here, is that X and Y have to add up to a total of 12 meters in length. Okay, and we'll take the time in just a second to solve that equation for one of the two variables, but I'm not sure yet, so let me skip that for now. Number 2 is where this problem gets tough. One of those two pieces that I just cut is going to be bent into a square. The other one's going to be bent into a circle. So the square, and I think this is going to be relatively small of a square right here, guys, is going to look something like that, and each one of the sides of that square all has to be the same. And what we can see here is that when we add up 1, 2, 3, and 4 sides of the square right here, we need to end up with a total here of X. And that kind of made me think that, you know what, maybe, no, let's not think about it too hard. So if the whole perimeter of that square is X, each one of those sides is going to be a 1/4 X. And that means that the area of our square is going to be 1/4 X times 1/4 X, and that's going to be a 1/16 X squared. Now, another way I was thinking about doing it would be making this 4X, and then each one of these just would have been X, and the area just would have been X squared. That might have been a little bit neater, but I'm going to leave this one the way that I had it here. Now, the second piece of wire is going to be bent into a circle, and Y is the total amount of wire that we have right there, which means that the circumference of that circle then has to be Y. And our formula for circumference is 2 times pi times radius, and that's going to end up equaling Y. That means that the radius of that circle all by itself then is going to be a Y divided by 2 pi. It's a little bit ugly right there, but okay. Now again, we're trying to minimize the sum of the areas of these two figures. So the area of this circle is going to be pi times its radius squared. Well, the radius we just came up with was Y over 2 pi. So the area of the circle, let's see, pi times radius, I forgot to square that, sorry everybody, pi r squared. So what's going to happen then is that we're going to end up with a y squared times pi in the numerator all over 2 pi times 2 pi, which is going to be a 4 pi squared, and that pi will cancel with one of those pi's. So the area of the circle looks like it's going to be y squared over 4 pi. So in step 2 here, we're trying to come up with a way to split this up so that we can minimize the sum of their areas. So I'm going to go with A for area here is equal to the area of the square, which is a 1/16 X squared, plus the area of the circle, which is a y squared over 4 pi. And right about now, it's decision time. Do we think that we want to deal with the X or the Y right here? Well, I'll tell you right now, this term looks quite a bit more complicated to me than this first term right here. That tells me that I want to go back to step 1 and solve that equation for X rather than for Y, which is what I normally do. So X is going to be a 12 minus Y, and I'm going to make that substitution right here, which is going to get me an area formula strictly as a function of Y. That's going to be a 1/16 times a 12 minus Y squared plus, I think I'm going to write this a little differently. I think I'm going to write this second area as 1 over 4 pi, which is all a big constant, times y squared. And with that in mind, guys, I am not going to expand this. I'm going to leave a of y as it's written right there, and I think I'm ready. No, it's not great. I think I'm ready to go on to step 3, which is to take the derivative of that equation we have right above. So this will be a prime of y, and that's going to equal, okay, let's see, it's the power rule with the chain rule mixed in. The 2 times the 1/16 is going to make a 1/8. Leave the base the same, 12 minus y to the first power, times the derivative within, which is a -1. And then plus, power rule here, bring the 2 out in front. That would be a 2 over 4 pi, or a 1 over 2 pi, if you like that better. And then just y to the first power. That's our derivative, guys, and we want to set all of that equal to 0 and solve. Let me kind of cut all of that off. Okay, so what can I do here? We can, let's see, we got a negative right there. Okay, so one thing at a time here. That's now a -1/8 times the quantity 12 minus y, plus a 1 over 2 pi times y. All that's going to equal 0. I'm going to distribute this to get rid of those parentheses here, and that is going to give me, I'm going to switch order here also, make that a 1/8 y, minus 12 over 8, that's a 3 over 2, plus a 1 over 2 pi times y is all equal to 0. Now, we've got 1, 2, 3 terms in this equation on the left side, 2 of which contain a y. So I'm going to take this one that is constant and move it over to the right side, and at the same time, I'm going to factor a y out from what's left. Pulling a y out from here is going to leave me with a 1/8, and from here, it's going to be a plus 1 over 2 pi. And all of that is going to equal a positive 3/2 now when we bring that to the other side. Ooh, so we're about to get a weird expression right here. Y then is going to equal, okay, 3/2, and now it's going to be divided by this quantity right over here. So, ooh, that's like a 3/2, and I'm going to put that on the bottom now of a 1/8 plus 1 over 2 pi. That is a really horrible expression right there. And I think I'm just going to go to my calculator and type that in just the way it looks, as ugly as that is. So let's jump to the calculator here. Let's go to a stacked fraction, 3 on the top, and in the bottom, 2 times in parentheses here, we had a fraction inside. That's a 1/8 plus 1 over 2 pi. So let's see if we can get that in there. 1/8, okay, gotcha, and then a minus, another fraction now, and it was a 1 over a 2 pi. Where'd you go? Right there. Was that minus? Nope, I was wrong. That was a plus. That didn't sound right when I said it. Okay, so change that minus to a plus. Whew, and that is ugly, guys. I'm going to go right and hit Control-Enter right here, and I get 5.279 for the value of y. 5.279. Now, we knew, let's go way back to the problem right here, that the total length of wire we were dealing with was 12 meters. So any value that we got bigger than 12 would have been impossible. And I was kind of thinking that those two pieces would have been split relatively evenly, which would have been 6 and 6. So getting an answer in the neighborhood of 6, but not quite, feels pretty realistic to me. I think I feel pretty good about that. All I think I need to do now is take this value back up to this expression right here, where we said x is equal to 12 minus y, and that should get us the length for x. So right here, I'm on to step 4. That's actually part of it right there, and say x is equal to 12 minus y. So x is equal to, I think I can wing this, guys. I think that's going to be a 6.721, if I'm not mistaken there. Yeah, I think that's right. And that's going to be x. And I think I've answered the question. Let me go back and check. How should this be done in order to minimize the sum of their areas? So that y quantity that we just came up with right here, that's how much we were going to use for the circle, and the x quantity is how much we were going to use for the square. And let's see, I think I have this document actually open right here next to me. Again, this was number 8. Sorry, guys, that's Fun to scroll through here. Number 8, 5.279 meters of the wire goes to the circle, and 6.271 meters of the wire goes to the square, and I think that's what we came up with right there. Okay, so that is how you would handle problem number 8 in the 4.7 packet.